these and go vice versa between them. So in this, we're just going to do some practice here. Now this is going to be a little quick, okay? Within this, I want you to understand that if you're struggling with this, you need to do a couple of things. You have the videos that you can go back to, of course. You can go back and check those out and that break down the individual rules. And then you have the videos within those that also are got practice problems that we're doing throughout. But if you still need more help from that, come see me. I've had a couple of you come see me during lunch, but not a whole bunch of you guys have came and seen me, okay? So if you have questions, stop waiting and come see me. So here we go. Let's work this answer key. And we'll alternate between some colors here. Just keep things for us. Okay, so in this, number one has KOH. Automatically I look and I notice there are 3 elements present. So potassium, oxygen, and hydrogen, which tells me there is a polyatomic here. Now I need to find the polyatomic. So in this, I found the polyatomic. It's OH. Okay, that is hydroxide. Knowing your polyatomic ion sheet, which I gave you guys forever ago, if you look at it, you have hydroxide, which is right here. Okay, so you need to know those polyatomics. So hydroxide. Now in this, before it, you have K, which is potassium, and you need to know where it comes from the periodic table. Potassium's here in the first column, which means it has a fixed charge. Therefore, we will name it based off of monatomic ion rules. So we have K, which is potassium. OH, okay, this is not an anion, so on this we're not going to name it by an anion rule. We're going to name it based off the polyatomic it is, so hydroxide. And I know I capitalize these on this when you don't have to capitalize them, okay? I'm not going to deduct points if you do or you don't. Alright, so don't worry about that. Number 2, moving there, we have CuO. There's 2 elements here. Since there's 2 elements, I know I look for a charge. 2 elements. There is no charge, which tells me it is not a polyatomic, so I move to asking what type of bond is here. Okay, so is hydrogen first? That's the first question I should ask myself. Hydrogen is not first, Cu is, which is copper. So what type of bond is this? Cu, which is copper, is a metal, and O, which is oxygen, is a nonmetal. So a metal and nonmetal form ionic bonds. Then I look at my cation, which my cation is copper, so Cu, and ask, does it have a fixed charge? Since copper comes from the D block, it does not, which means we have to use stock systems, so copper. And then in parentheses, we're going to put this charge of this copper. Okay, we have to find it, and you do that by looking at the anion. So we're going to look here at this anion, that oxygen, and there on that oxygen, when we're looking at it, the charge of oxide is -2. Well, I have one of those, which means the overall charge is -2 times 1, which is -2. In this case, since the overall charge of the negative part is -2, that means the overall charge of the positive part has to be +2. So +2, we'll divide that by the number of cations we have. So +2 divided by 1 is +2. It's a 1-to-1 ratio, so it's copper 2 oxide. And we're getting that from taking oxygen, removing the ending, and adding IDE. So then we're going to move to this next one. Number 3, HCl. There's 2 elements present here. And this is the thing I've really stressed with you guys. This is an L, it's a lowercase l, it's not a capital I. Okay, so don't think this is hydrogen, carbon, and iodine. This is hydrogen and chlorine. So, not a polyatomic, so then I look. What's the first element? It's hydrogen, which tells me something. If it's hydrogen, I'm dealing with an acid. So now I got to look and say, what type of acid am I dealing with? Out of those two acids we learned the oxy acids and the binary acids. In this case, there's two here. There's hydrogen and chlorine, two elements, which means it is a binary. And when we name binary acids, we include hydro for the hydrogen. We throw in the root, so chlorine, the root is chlored. So CHLOR. And we remove the ending, so that INE you take off and you change it to ic. And remember, we have to put acid at the end. Alright? You must put acid. If you do not, you are wrong. So then we look at this next one. Going to the next one. On here, number 4, we have H2. Excuse me. H2SO3. In this case, look, there's 3 elements here, which tells me I have a polyatomic somewhere. Find the polyatomic. Well, it's this SO3. From there, look at the first element. The first element is H, which tells you it's an acid. It's an acid. There's a polyatomic with it, which tells you it's an oxy acid, and you can also look and say there's more than 2 elements here, so it has to be an oxy acid. Either way you want to go about it. So you're not going to use that hydro prefix. That's only for binaries. So in this, we have to find what this polyatomic ion's name is, and it's going to be based off that. So in this case, we have SO3. Think of the root. The root, okay, sulfur and oxygen is always sulfate. Sulfate is SO4 2 negative. So we have one fewer oxygen, O3, than O4. So that means this is sulfite. We can see that, that's sulfite there. So we're going to base that. That name is how we're going to change everything. So keep the root, S-U-L-F, sulf. In ite, remember, ite becomes us. O-U-S, acid. So sulfurous acid. Alright? It's a good one. Now from here, going to number 5, we have NO2. Stop before you name the polyatomic. Look at this. You have 2 elements, so look for a charge. Is there a charge on number 5? No, there's no charge there. It's 2 elements, so it's not a polyatomic. Since it's not a polyatomic, we look at the bond between it. Nitrogen's to the right of the staircase, which means it's a nonmetal, and oxygen's to the right of the staircase, which means it also is a nonmetal. So 2 nonmetals bonded together means covalent bond, means we use covalent bonding rule naming, and that uses the prefixes. So we're going to have nitrogen is the first one, it's the first element, and here's the thing. It only has one nitrogen, so we do not use the prefix here. The second one, you will always use a prefix, so it's 2, so it's di. O is oxygen, remove the ending, add IDE, so dioxide. And guys, like I said before, if you're still struggling with these and you're wondering more about these, come see me. And then outside of that, if you're still struggling, feel free to come see me, watch these, go back and watch the old videos as we went through the naming rules. Those links inside the reminder are still active. All right, number 6. Number 6 is a good one. Number 6 has PbSO2. There's 3 elements here, which means polyatomic. Find the polyatomic, SO2. So we're going to do what we did before whenever we have polyatomics. We're going to have to look at the root, find the name of that polyatomic. That's going to help us here. So I'm going to start with that. I have SO, which the root is sulfate, so SO4, 2 minus. It's just like above up there. Sorry, where you can see it. We have O2 That's 2 fewer oxygens than the root, which means hypo. So we're dealing with hyposulfite. So this polyatomic is hyposulfite. That helps out a whole lot. Now in this, look at the positive part, that cation that's sitting there. Pb, that's lead. When you look at lead, I know it's in the P block, but it follows the D block dude rules. It can carry multiple different charges. So we're going to have lead, and because it carries multiple different charges, we're going to have to put the charge in parentheses. I'm going to go on and write this hyposulfite down here. So now, I just have to go and find this charge. Okay, so whenever we're looking at this, what's the charge of the hyposulfite? Hopefully you can look at me and tell me that it's -2. So -2, how many of these hyposulfites do I have? You only have 1. If you heard me say that and you went, what? Why? That 2 is for that oxygen there. That's not the number of polyatomics that you have. It's not in parentheses. This whole thing, that SO2, is hyposulfite. Okay, look down here at number 10. You see this PO5 in parentheses? That's the polyatomic, and that 2 on the outside of that parentheses is saying there's 2 of that polyatomic. Since there's no parentheses here, there's only 1. Okay, hopefully you got that. If not, just come see me and I'll explain it. So -2 times 1 is -2. That's the overall charge of the negative part. So now we've got to find the positive part. So it's going to have to be a +2. Divide it by how many leads we have. There's only 1 lead, so it means the charge must be +2. So this is lead 2 hyposulfite. Alright? I believe you guys are doing good. Alright, so number 7. Number 7. We have 2 elements, okay? We have nitrogen and bromine. Since there's 2 elements, we look for a charge. There is no charge, which means no polyatomic. Then from here on this, we're going to look at what type of bond is there. Nitrogen's to the right of the staircase, and the bromine is to the right of the staircase, which means we're dealing with a covalent bond because 2 nonmetals bonded together. Since we're doing that, we're going to have to use the prefixes, which is how we name the covalent bonds. In this case, nitrogen, there's only 1 of them, so no prefix is needed. We just name the element. So nitrogen. Then we give the prefix of the second one. You always give that prefix. So tri for 3, bromide. Because remember, we're going to move that ending off and add IDE to the end. Alright? We're going to go to number 8. So going to number 8. N2S. So in this case, look for a charge. There is no charge on 8, which means it is not a polyatomic. Therefore, we're going to have to look at what type of bond it is. Nitrogen comes from the right of the periodic table, and so does sulfur, which means it comes from the right of the staircase on the periodic table. Sorry, correct myself there. Since it comes from to the right of the staircase on the periodic table, means they both are nonmetals. So a nonmetal and a nonmetal is a covalent bond. So we're going to use those prefixes like we had just before on number 7. In this case, there is 2 nitrogens, so we must use a prefix now. So it's di for 2, nitrogen, sulfur. Okay, sulfide here. There's only 1 of them. You must include the prefix. Monosulfide. You must always include the second prefix. Remember that, guys. Don't get in a habit of when that first one doesn't have that prefix with it. Don't get in the habit of just going and not using mono. You'll always have to use it on the second one. Okay? Always have to give that prefix. Let's slide this up a little bit. Okay? Here we are. Let's go for number 9, which is NO3 negative. So I have two elements here. Look for a charge. In this case, I have a charge. I have this negative charge there, which means it's a -1 charge. So NO3 negative tells me it's a polyatomic. Now you can do this one of two ways. You could have done the hard thing and memorized every one of those polyatomics, or you could memorize the ones you have to, like the roots, and work it that way. So N and O, okay, I'm looking for the polyatomic that's N and O. I know the root of that is nitrate. In that case, nitrate is, right over here, nitrate is NO3 negative. Now make a comparison. I know I marked through my 3 there. It's kind of bad of me. It was really bad. But make a comparison between these two. See if I can get it right. There we go. So on this, I have 3 oxygens and 3 oxygens. So in this case, this actually is just the root. It's just nitrate. Hopefully you're seeing some tricks there, okay? Like I'll put something that looks like a polyatomic, but it's not. Like up here at number 5, that NO2, okay? If you fell and thought it was nitrite, that's okay. It's okay right now, but notice there's no charge there. Down here, number 9 is nitrate because it has a negative. That's the key to this, okay? That is the key. So, moving on, let's go to number 10. So here we go. Number 10 is SR3 parentheses PO5 in parentheses 2. So in this, clearly there are 3 elements here, which means there's a polyatomic. Find the polyatomic. In this case, it's very simple. It's the thing in parentheses. So in this, we are going to have to look at it. We're going to need the name of that polyatomic. So phosphorus and oxygen in the polyatomic, excuse me, phosphorus and oxygen polyatomic wise, the root of that is phosphate, which is PO4 3 negative. So I'm going to make a comparison here. I have 5 oxygens here in this in my question, and I have 4 in the root, which means there's 1 more. So you should know that this is perphosphate. Hopefully I wrote it out nice. So perphosphate. So now we got to look at the cation here. So let's look at this cation at Sr. You should know that Sr is strontium. Find strontium on your periodic table. You will find it in the second column, which means it has a fixed charge. Since it has a fixed charge, it will not need the stock system. So we will name it. Let's name the cation, which you just named the monatomic, which is the element name, so strontium. Make sure I spell it right. Strontium. Remember, this doesn't need the stock system, so there's no charges needed there. Perphosphate. Name the polyatomic that's with it. So perphosphate. Okay? You're doing good there. So, on number 11, pH3. pH3 is kind of a little trick because you got to remember about hydrogen. Because whenever you look at it, there's only 2 elements here. There is no charge, which means no polyatomic. So pH3, when you're dealing with that, look at what type of bond is here. You have phosphorus, which comes from the right of the staircase, which means it's a nonmetal. But hydrogen comes from the left of the staircase, but you've got to remember that was the rule breaker. Hydrogen actually is a nonmetal, so it's a nonmetal bonded with a nonmetal, which means you are dealing with a covalent bond, so we're going to have to use the prefixes. There's only 1 phosphorus, so no need for a prefix there, so we just name phosphorus. So phosphorus. Always put the prefix for the second one, so tri, hydrogen, so hydro, so Di, Hydr, and then add IDE at the end. So phosphorus trihydride. Okay? Now, I want to take a moment here to stress, in case you have fallen into a trap of every time you think you see hydrogen, you think you're seeing an acid. Hydrogen was not first, so this is not an acid. This is a covalent bond. That's how you would name it. So number 12. We're looking at number 12. It's a fun one. We have SnF2. So we have two elements. Look for a charge. There is no charge on this. Since there is no charge, that means that we are dealing not with polyatomic. So we look at the bond. So Sn comes from the left of the periodic table, which means it is a metal, and F comes from the right, which means it's a nonmetal. A metal and a nonmetal means we are dealing with an ionic bond. Since we're dealing with an ionic bond, we look at that cation. So what cation are we talking about? Is this cation right here, that Sn. That's the positive part of it. 10. Remember, 10 is one of those that will carry multiple different charges, guys. So in this, we will have 10 parentheses. We're going to need that stock system to represent that charge. So I'm going into parentheses, and then we're going to name that anion, the F, which comes from fluorine, which just makes this fluoride. So 10 something fluoride. So look at fluoride. What's the charge on the anion? Fluoride has a -1 charge. I know that because it comes from the 17th column. -1 times 2, because that's how many of them we have, which will equal -2. So the overall positive charge has to be +2, divided by how many of those we got. In this case, we have 110, so that means it's a +2 overall charge, so it's 10-2. Fluoride. Okay? Going to 13. Now 13 is not a trap. 13, you have hydrogen and fluorine together. But in this case, what comes first? Hydrogen comes first. Since we have that hydrogen first, in that case, the first thing we notice, hydrogen means acid. So we are going to have to name it based off of acid rules. In this case, is it binary or oxyacid? There's only two of them, two elements present, so it's binary. So we're going to put hydro, because hydro is used for binary acids. Then we're going to put the root, fluor, acid. Hopefully you're catching all of these. Hopefully you're doing good at this point, okay? I really hope you guys are. If not, come see me, okay? Number 14. Excuse me. Number 14, we have P2Br4. So we have two elements present. Oh, sorry. Video's going to empty. So in this, there's two elements. Is there a charge? No, which means we look at the bond. Phosphorus comes from the right of the periodic table, just like bromine does. It comes from the right, so it's a nonmetal and a nonmetal covalent. We use the prefixes. So di, because there's two phosphorus, so we have to put a prefix in this. Phosphorus, tetra, bromide. Okay. Number 15, we have CuS. In this case, 15 and CuS have two elements. Is there a charge? No, means not polyatomic. So we look at the bond. In this case, we have Cu, which comes from the left. It's a transition metal, which means it's a metal. And we have S that comes from the right of the staircase, which means it's a nonmetal. A metal and a nonmetal form an ionic bond. Look at the cation. Cation, does it come from the D block? Copper absolutely comes from the D block. Since it comes from the D block, we will name this based solely on the stock system. So we'll have copper, and we'll have to have parentheses with a charge in it. S is sulfide. And then look, let's find the charge of that copper. In that case, sulfur has a -2 charge. There's only one of them, so -2 is the overall charge of that negative part, of the overall from all the anions. Then we have copper on the other side. We've got to find the charge of it, so +2. Divide it, we got only one of them, so it's a +2 charge. So it's copper 2 sulfide. Number 16. Number 16 is Fe2O3. On this, please understand, remember, what's in these parentheses are the charges, not how many of them there is. So in this, we see there is no charge. We notice that iron is a transition metal, comes from the left of the staircase. So a metal bonded with oxygen from the right of the staircase. A non-metal means ionic bond, but the cation is a D-block dude, so you have to use the stock system. So we're going to use iron, parentheses, there has to be some charge here. O, so oxide. Look at the oxygen. The charge on the oxygen is -2. How many of those oxygens do you have? 3, so multiply that together to give you -2 times 3 is -6. The iron has to add up to be that charge, but opposite in sign, so +6. Divided by how many of those irons you have, which is 2. That gives us a +3. So we are dealing with iron 3 oxide. Okay? Moving on to 17. 17 is BeCl2. In this case, 2 elements, no charge, which means no polyatomic. So we have to look at it. Be is beryllium, which comes from the left of the staircase, metal bonded with Cl from the right of the staircase, which is a nonmetal, which means ionic bond. Look at the cation, beryllium, which is atomic number 4, and beryllium has a fixed charge because it comes from that second column. So we literally name it based off the monatomic ions. So first one, cation, we always name it based off the element name. So beryllium. And then the second one, that Cl, we name it, but remove the ending and add IDE, so chloride. So now within this, we're done with 17. Let's go to 18. 18, we have Ca, parentheses, OH, in parentheses 2. Dead giveaway here. First off, you see parentheses, which means you're dealing with polyatomic. If you don't want to think of it like that, you can do like me and say I got 3 elements, so I have to have a polyatomic present. Find the polyatomic. I made it easy for you. It's in parentheses this time. OH. So in this, we are going to name this, looking at the bond-wise, it's an ionic bond because calcium comes from the left, and then you have the polyatomic. So within this, you have to name the monatomic cation, so Ca, which is calcium, bonded to the polyatomic. Just name the polyatomic. OH is hydroxide. Okay, moving from here, on number 19 we have CO. So 2 elements, no overall charge. Since there's no overall charge here, then what we know is we're not dealing with the polyatomic. Look at what type of bond. Carbon and oxygen both come from the right of the staircase, which means 2 nonmetals, which means covalent bond, which means use your prefixes. If you do not remember your prefixes, you need to come talk to me. Here are your prefixes. Yay. Or you can pause the video and take a screenshot, whatever you feel like doing. No, you're not going to get that on your quiz. I'm trying to test your knowledge. Come on. So it is We have carbon. There's only one of them, so we just named the element carbon. Second one, we always put the prefix, so mon. It's oxygen, so we're not going to do double vowels. We'll drop that one O. And oxide. So carbon monoxide. There is your front page done on Nomenclature Practice Sheet 3. So let's move to this back one. Okay, and I will point out, yes, I made a mistake. Thank you, Seth and Connor, for pointing out number 30 and 31 and how they're repeats. I apologize. So now we're dealing with names and we're going to the chemical formulas. So on the first one you started with chemical formulas and went to names, and now we're flipping it, okay? So number 20, hydrobromic acid. Here's the keys that we're looking at. The first thing you see is acid. Whenever you're dealing with the name, go to the beginning. Look and see if it has a prefix. In this case, and I'm doing this in purple because it's important. Hydro. That prefix hydro is only used with binary acids. Since you have that prefix of hydro, that means this is a binary acid, which means it is two elements. So we definitely have hydrogen because it's an acid. Now we have to find out what the second one is, which just comes from the root. Bromic. So bromine. So Br. Okay? Remember that hydro is only to be used with the binary acids. So, look at number 21, we have a copper 1 oxide. So Cu plus 1, O, oxygen comes from 16th column, so a 2 negative charge. Then we're going to cross these over. So this 2 comes down for the copper and the 1 comes down for the oxygen. So Cu 2 O. Alright, so remember that Roman numeral within those parentheses, that is not the number of how many of those metals you have. It's the charge of that metal. 22. 22 is a really good one. Mercury 2, so Hg 2 plus iodite. Iodite. So in this, think back and remember your rules. So we're dealing with iodite. The root would be iodate. Iodate is IO3 negative. Now, in this, you have to remember the rules. You've went from iodate to iodite, which means one less oxygen. So iodate is IO2 negative. So IO2 negative. Now I'm going to put a purple star here on this 22 because a lot of you guys have had this question on this. And I want you to see how this is going to work. It's going to work like it did up here on 21. We're going to take this 1 and we're going to cross it over here for this mercury. But here's where a lot of the questions have came from. With the whole parentheses thing, when to use it, when not to use it with these polyatomics. And this is a case where we will. The reason why is we need, take this 2, so this 2 comes down here for that iodide. This says I need multiples of my iodide. So it's Hg. 1 came down from the iodide. IO2. But 2 came down from that mercury. I have to have multiples of this iodide. This 2 is for that oxygen. That 2 is not from the mercury. Put this in parentheses. And then put the 2 outside. That's just evening out the charge. Okay? So hopefully that's helping you there. So, moving on, number 23. 23 is a good one. On 23, something should stick out to you. Chloric acid. We got an acid. Since we have an acid, remember what I said on the first one, on that number 20 there. go back and look at the beginning. What is there a prefix there? In this case, there isn't. It's just chloric. So hydro is not being used, which means you're not dealing with a binary acid, you're dealing with an oxyacid. So we have to base this off of the polyatomic ion that it came from. So let's look at this. Chloric acid. This is how I do it. Ic, acid. Where did it come from? It came from 8. So we're dealing with chlorate. Chlorate is ClO3 negative. So now we know what to start with. Okay, so in this on 23, it has to have hydrogen first. Why? Because it's an acid. Now, put the chemical formula for that polyatomic. So ClO3. Look at the charge on the polyatomic over here. It's a -1, which tells you how many hydrogens you need. I just need 1, so I don't need to write anything else with that hydrogen. 23 is done. Okay? So let's go to 24. I'm running out of time. We're going to have to pick a pace. So 24 is iron 3 nitride. Iron 3, Fe3+, nitride is N3-. I left this in here because it's a 1-to-1 ratio. So since you're in this 1-to-1 ratio, it just means you just write them down next to each other. So Fe, N. Alright, so moving on to 25. Hydroiodic acid. That does not roll off my tongue well. So we're dealing with an acid. Look at the beginning. Hydro, which tells you that it's a binary acid. So H. Find the other one that goes with it. Find that root. Iodide comes from iodine. So I. So HI. Hi. 26 is a really good one. I'm going to break up the madness here and I'm going to pull out the purple pen because it is a good one. Ammonium oxalate.
Camera Towers, Jacob Cochran, come to the office.
I absolutely did this to you. 2 polyatomics together. So you're going to have 4 elements. So ammonium is NH4 plus, and your oxalate is C2O. Sorry, excuse me. O4 2 negative. Man, this cough's killing me. So we're going to cross these charges over. This is another one that you can see with those parentheses coming in. So we're going to have NH4. That's our ammonium, but the 2 came from the oxalate, so we need it. We need 2 of them. We have to put that in parentheses and put a 2 with it. Then you just have oxalate, C2O4. All right. I'm sure that pops there. I want you to see that 4. That NH4 within parentheses, that 2, then a C2O4. Alright, that's a good one showing that parentheses again. Let's slide this up some. Alright, so moving back here, let's get back to the transition. So 27, barium nitride. Barium, Ba2+, nitride is N3-. We'll cross those charges over. So Ba3, N2. Alright, looking at 28, you got chromate. Chromate, it ends in that 8, okay, which tells you polyatomic. Remember the root, in this case this is the root, so chromate is Cr. O4, 2 negative. Sure that 2 looks good. Okay. So that should be working well for you there. Number 29, hydrofluoric acid. Hey, you got an acid. Look at the beginning, we got hydro, which means binary. So first element, hydrogen. Second element, we got to find the root, which fluor comes from fluorine. So F. Okay, if you're wondering why I'm only putting one hydrogen there and I'm not even looking at it, all those halogens come from the 17th column, which has that -1 charge, which just means I need one hydrogen with them. Okay, so number 30 and 31 are repeats. I apologize for that again, but here's the key. It won't be bad for you. Penta, you see a prefix, so it's spelled out for you. So iodine, there's no prefix with it, so it's just I. Fluoride, so F. Penta means 5, so I, F5. And I guess we'll just write it again, because Mr. Hall made a mistake. Isn't that great? So let's go to 32. Dinitrogen trioxide. Hey, di and tri are prefixes. So covalent bond, Mr. Hall gave you some love here and he spelled it out for you. So dinitrogens, N2, trioxides, O3. Then we go back to actually having to put some work into this. Gosh, why did I ever do that? Number 33 is iron 2 fluoride. So 33, Fe2 plus, fluoride is F minus. Bring these charges down. So Fe, 1 came down, so F2, 2 came down from the iron 2. So FeF2. Moving on to the next one, hydrochloric acid. Hey, got an acid. Look at prefix. Hydro. What does hydro tell me? Binary. Binary acid, first one is hydrogen. Then find the root. This chlor comes from chlorine. Arsenic acid. We have an acid. There is no hydro in the beginning, which means we're dealing with a polyatomic. So arsenic acid came from 8, so arsen 8. And hopefully you know your root polyatomic is arsenate, is AsO4, 3 negative. So hydrogen first, because it's an acid, then write down chemical formula, AsO4 from that polyatomic. There's a 3 negative, which means I need 3 hydrogens. So remember, this right here, that 3 negative is where I'm getting that charge from. Alright guys, I'm sorry that one did not turn out looking so good, but that's H3AsO4. See if I can get these done before my physics kids start saying, let the shin. 36, copper 1 oxide. So we have Cu plus oxide is O. 2 negative, cross them over. Cu2O. Okay. Cu2O. That U does not look good at all. Rewrite that. Cu2O. I guess I just don't like that U and 2 sitting next to each other. I think you can tell the difference. Hopefully you can. Alright, 37. Mercury 2. So mercury is Hg 2 plus. Bromide Br minus. Negative 1 comes down. 2 plus comes down. So we have Hg. I got 1 from the bromide coming down. Br.
Katie and Ethan Morgan in the office.
So there is that one. Now, barium cyanide. This is the one that does not, this is a trick. I knew this. This is a trick. Why? Because you see that ending IDE, but you have to remember what cyanide is. Cyanide is that polyatomic ion. So we have barium, which comes from second column, Ba2 plus. Cyanide is Cn negative. Negative comes down, negative 1 comes down, and positive 2 comes down. So Ba, but we need 2 of that cyanide, so Cn2. Okay, hopefully you caught that, hopefully you got that. Then in here, the last one, I made it, hallelujah. Hyposulfite. Figured I'd leave this one, be a good little trick to leave you with here. Hyposulfite, so in this, sulfite comes, the root of this is sulfate, which is SO4, 2 negative. Hyposulfite, so hypo and ite means 2 fewer than the root, which means I lose 2 oxygens here, so it's really SO2, 2 minus is hyposulfite. So SO2, 2 negative. And that is the back of your nomenclature practice sheet 3. If you have questions, feel free to go back and watch those videos, guys. And if you need more help from there, come ask me. I'm fine with you coming and ask me. I know this is difficult, but this is basis, background, and foundational. So please, don't hesitate to come ask.